Hey everyone, welcome back. Lesson 8, last lesson of the Perms and Comms unit. Um, we are going to look at this, but we're just going to revisit for a moment a page from lesson 7. So let me bring that up and we'll take a look at that. Okay, on page 416, they had basically the binomial and all these different binomials expanded, and we noticed that there were several things to note. If the exponent was like n, then there would be n plus 1 terms, and you have this filled in already. The sum of the exponents in each term is n. The exponents on x decrease by 1 all the way from n to 0, and then the exponents on y increase by 1 term by term from 0 to n, and the coefficients form a symmetrical arrangement. Okay, so what we're going to do is we're actually going to revisit and do some expansions of some binomials by using these patterns that they mention. Okay, so I think what we'll do is we'll go and do these expansions on some blank paper in the back of your workbook. So find that or on scrap paper, either one, and keep it with this lesson, okay? So let's do that, and I'll bring up that as well. Okay, so on a piece of paper, if you can please copy this question down, and then we'll work through it together. Expand bracket 2x minus 3 and bracket to the 4 exponent using binomial theorem. Okay, so we're going to use our patterns that we learned in lesson 7 first. So we have an exponent of 4 here. That's our n value. But it also tells us that there is 4 plus 1, or 5 terms in the expansion. So because we know there's 5 terms, I myself like to do these terms in the expansion vertically. So I would like you to do 2 sets of brackets. And we're going to do 5 rows of them, 1 row for each term. Okay, now within the first set of brackets goes whatever's the first term is, so 2x all the way down like that. Second set of brackets goes the second term, and it includes a sign in front of there. So if it was plus 3, you'd just write 3, but since it's negative 3, we write negative 3. Okay, now remember from our patterns we discovered, the exponent on x, or in this case 2x, starts at whatever our n value is, 4, make sure you put it on the outside of those brackets, and then decreases by 1 until we reach 0. And this is why I do it vertically, because it lines up so nicely. And then the exponent on y, or in this case negative 3, would start at 0 and increase by 1 until you reach 4. Notice within each of these each of these terms, the exponents add up to the n value. 3 plus 1 is 4, 2 plus 2 is 4. That's something else, a pattern we discovered from the last lesson. Now, in front of these are either a row from Pascal's triangle, or those are also known as combinations. And this NCR that we're about to write down, n is our exponent on a binomial, so 4. So it's going to be 4 choose something for each of these. And then the last number, 4 choose k. K is our last exponent, kind of on our y, if you will. So 0 in this case, 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, whatever this last exponent is. But also, those are in Pascal's triangle, so of course it goes from 0 to 4 as well, as we discovered in lesson 7. All right, now for each of these, we are going to simplify them. So I'm going to write little arrows to simplify. 4 choose 0 is 1, and you know the numbers on the outside of Pascal's triangle are all 1. So, and it's symmetrical, so that means this last one is going to be 1 as well. 4 choose 1. Anything choose 1 would be the anything part, so 4. And again, symmetrical, so that means this one's 4. 4 choose 2 is equal to 6. Okay, let's simplify the next part. 2x to the 4, so it's got to be 2 to the 4 and x to the 4. So 16x to the 4, negative 3 to the 0, anything to the 0 is equal to 1. Okay, 2x cubed, going to be 8x cubed, times negative 3 to the 1 is negative 3. Okay, 4x squared, positive 9, negative 3 squared, and 2x, negative 3 cubed, negative 27. And finally, 2x to the 0 is 1. and 81 for negative 3 to the 4. Okay, now we're writing it horizontally. So the first term, you multiply all those numbers together, 1 times 16 times 1, and you get 16x to the 4. Next one, 4 times 8 times negative 3. So we would get negative 96x cubed. Next term, 6 times 4 times 9 is 216 x squared, and then 4 times 2 times 27, that's going to be 54 again, times 4 is going to be 216 again, but negative this time, and x, and then lastly 1 times 1 times 81 would be plus 81. And there we go. Those are our 5 terms in the expansion of 2x minus 3 to the 4th exponent. Good. Now we're going to try another one, but I want you to do this one. Okay, so we are this time going to expand, let's see, x squared, I don't know why I wrote that so high there. Okay, x squared plus, let's see, 2 over x to the exponent of, oh, I don't know, let's go 9, let's say. No, that won't work, we need 10, sorry. Okay, so here's what we're going to do. We are going to, actually I'm going to change that to an 8. Sorry, hopefully you're writing in pencil. Okay, so we are going to, oh, that's a lot of terms. Okay, hang on one sec. Let me get a proper exponent there. There we go. Now I got it. Okay, so exponent of 6 on that. Okay, so I would like you guys to do the full expansion here. Take note what the exponent is and how many terms there'd be, so how many rows of brackets. Fill them all in. Just basically do what we just finished doing on question 1. And then we'll check and see if we have the same binomial expansion. Okay, so pause your video, go ahead and work on that, and we'll check in a bit. Okay, just thought I'd stop partway through so you could check your work. So we filled in all the first sets of brackets. We should have 7 terms because the exponent is a 6 and the number of terms is always one more. And you fill in the first set of brackets x squared, second set of brackets 2 over x. Exponents go from 6 to 0 for x and from 0 to 6 for y, but y is actually 2 over x. And our NCR, which we can't forget. Okay, so let's keep going. We'll simplify this and then we'll come up with a overall how many terms written horizontally here. Okay, so pause your video and finish that one up. Okay, so here's our full expansion. Please note that one of those terms, you see that 240 there? The x's actually ended up canceling off completely, and that means this term is called our constant term, or sometimes referred to as term independent of x, okay? And that can happen when you have x's here and x's here, but one's on the top, one's on the bottom. We also had a constant term up here, but not quite the same scenario with the x's canceling. We're going to be looking at how to find that constant term later on. All right, so remember this. Pause your video if you still have to check your answer here, but we're going to go back to lesson 8 now and do some of the examples on there, okay? So go back to lesson 8, pause your video. Okay, well, let's take a look at this example in lesson 8, example number 5. We're going to do this one because it kind of follows nicely with what we just did with the full expansion, except I'm going to be doing it a different way. So you can kind of ignore what they've got written there, and this is where we're going to solve it here, and this is all the room we're going to need. So the question says, one term in the expansion of x squared plus a to the 8 is 114,688 x to the 4. Determine the numerical value of a if a is greater than 0. So in other words, we don't know one of the terms. Okay, so what we do is we're not going to expand the whole thing, and because there would be 9 terms and that would be a lot of work. So we're just going to simply do one term. Okay, so when we do that, we do the 2 sets of brackets. In the first set of brackets goes your first term here, so x squared. In the second set of bracket goes your second term, which we don't know, but we'll call it a because we can solve for it. Okay, and then we don't know the exponents yet. We'll talk about that in a minute. And there's something, choose something in front. And we know if we were to simplify this, that the answer would be 114,688 x to the 4. So we can write that as that being equal to that on the right-hand side. Okay, now if you look at this term has x to the 4. A is not anything to do with x, but x squared is. So what exponent would have to go on the outside of these brackets here, where we have x squared, in order for us to get x to the 4? Well, exponent and exponent, we multiply them. So to get 4, when we start with 2, we'd have to have another 2. So 2 times 2 is 4. Now, if you recall from our patterns that we know about with binomial theorem, these two exponents on the outside here have to add up to our n value, which is 8. So 2 plus what gives us 8? And that means that would have to be a 6. Okay, now we have something choose something in front. This is n choose k. N is what our exponent was, 8. And k is whatever this last exponent is. Okay, so in this case it's a 6. And there we go. We've got basically just have to solve this now. So we get on our calculator 8 choose 6. So off to the calculator. Let's figure that out. And I kind of know that already. So you should be getting 28, I believe. X squared squared is going to be x to the 4. I guess we don't need brackets anymore then. We can just write 28 x to the 4, a to the 6 equals, right hand side still the same. Okay, now our goal is to solve for a, so if we divide both sides by 28x to the 4, 28x to the 4 on the right hand side, that'll get a to the 6 alone. And here we're going to have to grab the calculator and divide 114,688 divided by 28. The x to the 4s will cancel. Okay, so let's go get that number. So we should have gotten 4,096. Now the only other thing we need to do is to get what the 6th root of that is. So we've got to get rid of this exponent of 6. So we're going to 6th root both sides. So on the calculator, what we want to do there is go math, and we're looking for the x root, number 5. Oh, sorry, we have to type in 6 first. So we're telling it's the 6th root of, and then we want of the answer we just had, so second answer, and there we go, we get 4. So that means a is equal to 4. Technically plus or minus, but they said up here that a had to be greater than 0 because, well, that's what they stated. It would be plus or minus because it's an even root, essentially. And there you go, found a without having to do all this stuff. Okay, let's look at another example. Okay, on the next page we have example 6. Determine the numerical coefficient of the term containing a to the 7 in the expansion of 3 minus a to the 10. Okay, I'm not going to expand all of them. We're probably not going to need all this room, but we're going to do one term in the expansion, so 2 sets of brackets. We know the first term here, 3, goes in the first set of brackets. Negative a goes in the second set of brackets. And we want the term that would have a to the 7. So let's see, in order to get a to the 7, we would have to have a 7 exponent on this factor here. And to figure out the other exponent, we look at what our n value is, which is 10, and these exponents have to add up to 10. So that means this would have to be a 3. 3 plus 7 is 10. And don't forget about your NCR or NCK in front. Our n is 10, so that'd be 10. And the k value here is the last exponent here, so 7. Good. Now, if you were asked which term this is in the sequence, if k is 7, like basically if k is 7, we actually have the 8th term, but we'll get into that more when we look at the formula. Okay, so let's simplify this using our calculator. 10 choose 7 on the calculator. So we would have gotten 120 with that. 3 cubed is 27. And negative 1 in front of the a, if it's to an odd exponent of 7, that would still be negative 1. Had it been a 6 or an 8 or something like that, that'd be now positive. And then a to the 7. Final step, multiply 120 times 27 times negative 1 all together, and that would be our coefficient in front of a to the 7. So grab your calculator and let's do that. And we would get negative 3,240, and that would be our numerical or number coefficient in front of a to the 7. All right, good job. So we're going to do example number 7, but we'll do that in part 2 of this video, and also some of the previous examples that we skipped in the first part of the lesson. Okay, so we'll see you in part 2.